So good evening everyone. I welcome to my third tutorial. So if you haven't watched my first tutorial and my second tutorial, I will first of all recommend you to go back to my first and second tutorial, watch them, and then come to this third tutorial. So it'll be much easier if you can follow along with my tutorial. So I'm trying to make it so easy and so understanding for everyone. So if you find it's kind of like redundant or whatever, don't be upset because yes, I just want to make it that everyone maybe who has no experience with Python, no experience, I don't know, no experience with data analysis and data visualization also then can really follow along. So that's why I'm repeating it once more so that everyone gets it right. So I assume that if you have watched my second tutorial that you have access to this notebook, but I will just kind of reminder. If you haven't, I already attached to my second tutorial a link to GitHub, so you can go over GitHub and then you have two possibilities. You can clone the code whatever we have in here. You can download this, and then you will have it, or you also have or you can clone it. Then you have all the presentation, and also you have the notebook. The other option would be that you go to your Google Drive, and from Google Drive you go to New, just left open, then More option, and then you create a collab. So if you click on this, you will create a collab notebook, and you have if you have a collab notebook like this, let me show you. So just create. You have already created a collab notebook, and then you can name it the way you want, and then you can go to GitHub, and then you can copy the code from GitHub, and then you can start. So this is the easiest. So you can just Control A, case Control A, and then you can copy everything. Or for my case, I can copy cell by cell. So I can copy this one, Control C, and then I can paste it over here, and then you can start also doing what I'm doing. You can follow along. So it just take you a second, some 5 seconds, and then you have the code in your drive, and then you can follow along. So I'll go back to yes, to my notebook, and then I will proceed where I started from last time. So last time I talked about the libraries that we were using, and today I would emphasize more about the libraries that we're going to use today for data visualization. So we are using Bokeh, Bokeh framework, similar. If you have worked with, you have R experience. In R we have Shiny, and in Python we use Bokeh for as a front end for visualization. There's a front end framework for visualizing your data and so on. And here in Bokeh we will need one of the most important library, IO. And so we're gonna need two functions. We're gonna need the output notebook, and then we're gonna need the show function. We're gonna need the output file. For the output notebook, we're gonna put it almost in every cell. So if we want to have uploads displayed here in our collab notebooks, we'll have to call this function in every cell. And then we will have the output file if we want to export our dashboard in form of HTML page, and then we can share the HTML page with our end user. So the end user will not see the Python code we have here, but only will see the plots, will see all the diagrams, our dashboard, and he has no idea from the Python things that you're doing here. So he won't have idea about this. And the other model library we're gonna use from Bokeh is we're gonna use the models, as Bokeh models, and from Bokeh models we're gonna import the column data source. We're gonna import a column data source we'll be using to convert the pandas data frame to a column data source. This makes it easier for us to really process and work with this when we're using Bokeh and so on. So visualization, so it really needs that you convert. Sometimes you have some errors if you don't convert your pandas data frame to column data source. Yeah, and then we will use the select function from Bokeh models for drop down and some other functionalities like custom GS function. We'll be using this one if we are writing Java code. For example, if we want that, if the user selects if we select a certain stock, then we want the data to be displayed based on the selection and so on. So we want it to be dynamically adjusted depending on the selection we have. So we will have to write some Java code, and we will need the diff if we will need. So this will make things easier if we instead of just writing like the HTML code, will be just using some functionalities that the Bokeh model brings, which is much really easier. And I will show you as we move on. And then we're gonna need the data table function in the table column. The data table will enable us to display our data frame, for example, as a table, and then we on our dashboard, and then we will use the table column function to define the column names for our data table. And then we have the plotting, Bokeh plotting. Here we will import the figure function, and we use for every new figure that we create, we will have to use this function. And then we have the layouts, and the layouts, this will allow us to if we want to structure our dashboard and so on, so we will define some layouts like column and row layout and so on. But we will see this in exam so that we can understand it and follow it much easier. So this is the important thing, and these things here, the libraries we're gonna need for our visualization. So just as we did last time, we have to connect connect it, and then we can execute our fast cell. So we execute it, and then we will have to authenticate ourselves and authorize Python in order to communicate, to write and read from our Google Drive. So we're gonna do what we did from last time. So, and okay, just the same step as we did last time. So, and then we copy this and we paste it over here. So, all right. So, and then I won't repeat the function. If you have questions, please let me know, but I won't repeat this function that we discussed last time. So I'll just start from where we start. So just as a reminder, here we have our historical data for all of our entities that we define up there. So these entities can be adjusted. So if don't know, we can remove any of this. I say I don't want MC. I can remove this one, or I don't need this one here too. I can remove it, and I can remove yeah. And yeah, then here maybe I say I need Facebook. Then I can execute this and execute this. And here I have my historical data, and this is what we'll be gonna be analyzing. So this here we have our historical data and so on, and we have created a new column for our entities and triggers. So that's what I showed you, talked about last time. And then here we did, that is where we stopped last time, and we'll execute it. So here we did the descriptive statistics. We did this descriptive analysis, and yeah. So here is where we are saving our descriptive statistics, what we have calculated. That is where we are saved. So if we go here, we will get all this stuff. Here's grouped per entity, per year, and per month. Here was just general statistics, and so on. So, but if you have a question about this, please let me know. So I will start from here, and this one. This is a mean absolute percentage error function. This is normally we use in order to calculate the performance of our model. So we have the predicted value, we have the actuals, and we calculate the mean absolute percentage error based on the true and based on our actuals and our predicted values. And but this function we're gonna use it. I think I will explain more about this when we have our coming tutorials. So there's a specific tutorial about this where we will be hyper tuning some model parameters in order to select the best parameter and so on. But for this tutorial we won't need this. And then for like correction and so on, I want to talk about this. But if you have questions, I might explain about this maybe in some coming tutorials. So but however we still have to execute this notebook because there's one function here that we're gonna need. So this function is output type. So we have two possibilities. We can display our plots in a notebook, or we can export as a HTML page. This is what I define the function here. So I will be calling this function, and then if I want to have it displayed as a notebook, I just have to put true, and then this function will call the output notebook that we imported up there. So I showed you last time. This is over there. That's what we imported over here. Output now exactly this one here. Yes, and then if we have this, we will also have the second possibility where we want to export our dashboard in our Google Drive, and then this is the name of our dashboard. So if you can customize this name, and then you can give the title to your dashboard. So this is what we will be sharing with our end user. So all right, so we have to execute this one here. So after all this, before we go to data visualization, we want to make some predictions. We want to do time series analysis, and as I said, we're gonna be using a model called a VECM, vector error correction model. This model has an advantage because a multivariate time series analysis, which means we can make forecasts for more than two time series variables. So if I have, for example, in our data we have a lot of we have at least I think we have 6 numerical column values and so on. So we're using this model to allow us to make forecasts at once for all these numerical values. And this really has an advantage because I don't just want to make forecasts for closed values I just want to make forecasts for high, for low, and for on. So I have to use this model. This is an advantage using a VECM model, and also the model has also advantage because it's about some causation effect. So the development of one time series causes or influences the development of the other time series. But I will talk more theory about VECM in coming tutorials. So this time I just want you that out of the box to execute this cell and then do the prediction and then visualize the prediction. But for the coming tutorials, I will go deeper and some mathematical functionalities that we will be that we use here in VECM. So what we have here is you have your data frame. You have these tips that you want to forecast ahead, and you have the seasons. So this depends on either you have yearly data, monthly data, the frequency. So if you have the yearly, monthly, so yearly will be 1. If it's monthly, it will be 12, and if it's weekly, if you have a weekly data, it will be 52, and if you have daily data, depending if you have like business days, so it will be like 252 or whatever. But you have like normal days, then it will be 365. And then here I'm just using a response value because we are also doing kind of a response analysis. And but I will talk more about this because there is actually another topic, and it will need more time to talk about it. And then here we just have to put the start date, and for our case we are making forecasts based starting from today. So this will be done dynamically, and then we have the frequency. So we'll be having like business days, like so if it's business days, then you have the frequency will be block letter P, and if it's like weekly, then it will be V, and so on. Yes. So this if we have to just run this cell, and then this is functional programming. So please don't mind about all the functionality here. Maybe from next tutorial I will take time and then talk about all the everything we're gonna do. So here we just define the model and everything and the parameter, and then the second cell is where then I also define specifically for depending on our data now. So I define here prediction function, and I want this is specific for our forecast. So this is a general function, but this is now specific for our use case. So what we're gonna do is we have our data frame here, we have the steps ahead, we have the seasonality, we have the response, just the same like the up there. But what I do here now, I take the columns dynamically from my data frame. So I have like 6 columns. I will get the 6 column, and then I can say print column, and then it will give me the names of the columns from my data frame. And then what I gonna do is I gonna because we're dealing with big data problem, so I gonna define I gonna get my entities. So this is my triggers, my stock, unique stocks. So dynamically, so if I define 11 stocks, I will have 11 stocks. If I define 10, it will be 10 stocks. And for every entity, for every trigger, I want to make prediction. So just similar to like a descriptive analysis, but this case we are doing machine learning. So this is actually we are training our model, and then making forecasts for every stock, for every trigger that we have defined in our default list. And so here we can query our data frame, and we filter only based on this current value iteration, and then reset the index and so on. And then we're gonna set to make sure that because time series analysis requires that your data is actually sorted in ascending order. So you have like that is time series development. So if you have your data must be sorted in ascending order. So from 2011 to up to 2021 and so on. This is what we are doing here. We sort, make sure that our data are sorted. And then what I do is I remove I don't need if I have year and so in my data, so I don't want to have this column in my data. I'm not interested in this one. I just want to make forecasts for the low, for the high, and also for the open, for the high, for the close, and for the low value. This is what we're gonna drop all other columns that we are not interested in. So we're gonna print and see, okay, we have dropped them. And then now we're gonna call this function inside our prediction function. So here we have defined some specific use case for use case, and then we're gonna call this this function that we defined up there. So this is a function we defined up there, and this is our model. This is the machine learning things that we're doing here. But I will talk about this in some later tutorials. So don't worry about this. So you don't need to understand this, but you just use it out of the box. Yeah. So you can use this function even for your custom data. You don't have to have the same data like what I have, but what you need is just to customize this function. So if you can change here, you can just change your entity and so on. So you can customize this function, and you will have this code run to any data that you have, any your custom data you have. You just have to customize some functions here. Just change some function, and then you will have this running on your data and so on. So I gonna drop that function, and then I gonna call this function, and then after I've done this one, so we are making prediction for every entity, and then we're gonna add this column in our new prediction. After we have trained the model, we make prediction. So just remember the first tutorial, and this we're gonna then call it the current name. So dynamically call it the current entity name, and then we're gonna do it for all the entities. So that's why we're attaching this one to the previous data frame. So at the beginning the data frame is empty, but after one entity, so we have some entity prediction for one entity, and after the second we'll be getting some data and so on. So appending and so on until we are done with all the entities. So after we have done all this, so this a function ends here, so we return the prediction. So this is what we return the prediction, and we are resetting the index, so we don't resetting the index and so on. And so this is how we call the function. So we call the function, and when we call the function, here this the data frame that we're giving as a data frame, and this is the data frame that we created over here. So I will show you. This is our data frame. So we added here. We took our historical data and just did some field engineering, adding year and column. So this is what we are now doing. So this is what we're using for machine learning, for making prediction. So this is what we're doing here. And then we want to make forecast. Let me say 10 days ahead. 6 days too much. So I say 10 days. And then because we have daily data, as you saw from the first video, we are taking this daily data from Yahoo Finance, and our response value will be the close value, and our start date will be, we're making forecast as from today, and then the frequency, we have business days and so on. And then there is what we call a response analysis. So, but I'll talk more about this. So this is about in case we have a shock, for example, let me take this. We have a shock in high value. How will the open value respond? That is for long term and for short term, and so on. But I think I will take time and have a tutorial about how the response analysis works and so on. So after we have done this, so if you execute this one, so you are doing here, this is where you are doing machine learning, training the models for all the entities you have, and then making predictions and so on. So you will even see some kind of outputs here and so on. So but there's more about the model, about the VECM model and so on. So here what we also have, we define a confidence interval of 80%. So we have the high, and then we have the lower boundary, and we have the upper boundary, and we have our mean forecast. And I think we will visualize the data, and then you will understand more about this. So for every column, for every numerical column, like open, we have 3 values. We have the open lower, and then we have the open value, and then we have the open upper boundary and so on. So for example, for Apple, we say that we made prediction, and there's a value, the lower upper. So there's what we define. So this is what we predicted. One will be a line between these, and so this is the interval that we are 80% sure that the predicted value will lie between this interval, and so on. So this is what we that's what we got. And now after if we execute this one here should so this is the prediction that we're predicting for today, for it, also for tomorrow. So this is because tomorrow is a business day. So the open value will lie between will lie between $147 to $149, but the predicted value is $148. So you can look at the value, the Apple price. This is our prediction for the next 10 days for Apple and for Facebook and so on. And so here you have the prediction. And now what we're gonna do here is, now we want to visualize our data. So after prediction, so on, we want to put everything together in a notebook. But before I do that, I just wanna have to filter my data, just to have the mean value, max value only for 1 month, because if I have it for all months, this is too much. I don't want to visualize everything, so I just filter for the low value for I just want for September and so on, for this September. So that's why I filter the index standard deviation, and so for this will give me the standard deviation for all triggers, excluding some triggers here. and I'm gonna filter the year 2021, and then the month greater than August, then 8, so it will mean September, and so on. So this will be standard deviation, and this will give me the mean, and this will give the minimum, and this will give me the mean value, and this will give me the max value. So this is what I will get if I filter. And then we're gonna set the index to be our NDT column or our ticker, because we want to have like a bar graph as well, a bar chart and so on. So in a bar chart will require that we have an index column, and if I execute this column, we will have this output. So this we selected only so here we can also, okay, maybe before, so we are querying this function, and after querying we can use two brackets here, the space brackets here, and then we can select the columns that we want from our data frame, out there. So we're only selecting 3 columns, so that is what we are selecting. So you can use this functionality to select specific columns and so on. So after we have selected these 3 columns, we are setting the index to be the entity or ticker, and then we have the close value. So if we have this format, we can now easily start plotting our data, and so this will be our first bar chart. And so we can now so the other thing that I'll forget about, so if you have your data frame here, because we have already installed this pandas Bokeh, now we can access every functionality that this data frame allows us. So we can access in this case we have the Bokeh bar chart, but we also have some other like line chart and so on. So you can really use this function, and then you can have, for example, horizontal bar, you can have like a line, you can have a map like a T chart and so on, pie chart, map, line, and so on. So with just easy with just some few lines. What you need, you have to give your Y label. For example, for my case, standard deviation for high and close value per ticker, and then you can give the title for your plot. So what we're doing here, and then you give the transparency, the alpha, and then here so depending you can say 0.6, pretty much transparency and so on. So if you do like this one, you already have your plot. So you take your data frame here, just so easy. So just it's like that one. You can you have already your plots here, and then you can download this plot. So if you can download, if you have saved it, you can download it, and then you can zoom around and so on. So you have all these functionalities with just simple code. You have this this nice plot. So we're gonna do this that is for standard deviation, and then we're gonna do this for mean, for max, and so on. Just the same way. So you can copy paste. Yes, but in this case we're gonna have a horizontal bar. That's why I'm using this one, H bar. So if you have any question, please let me know. Otherwise, if no question, I will move on to up to here maybe, and then I will stop here. So so the other things here, what we are gonna do, we're gonna use the pandas Bokeh, right? And then we're gonna use plot grid to put all these plots together now in just one single layout. So this, if we execute this one, so we have all these plots in one layout. So cool. So that is our first part of our dashboard. So and then we can download this. We can download this. And then I think it will download over. I think you want every plot to be downloaded dynamically, but you can't. I just realized you can't. I thought maybe you can download the whole plot at once, but you will just download a single plot per time and so on. But no problem, you can make a screenshot and then you can also share with your end users. So this is the first part of your dashboard. So the second part, we're gonna put everything together. This is just for the descriptive statistical analysis, it's for mean, standard deviation, for minimum, and then for marks and so on. But the other thing is we want to put prediction on everything all together, and this is what I'm gonna do in this in the next tutorial. So